If this prosthetic arm looks familiar, it's supposed to. Its designers patterned it after Luke Skywalker's arm in Star Wars that can move its fingers independently. The idea behind it was a lucky accident.
We tried to have EMG controlling and finger-by-finger control, and we failed. And then we have a eureka moment because when we tried it, it was next to an ultrasound machine, and we said, let's look at the muscle. And we put the ultrasound, and we saw the muscle maybe shooting the same way, the same level of electric activity, but it moves in different locations.
That means that prosthetics, which just read electrical signals, cannot tell which finger the muscle is trying to move. But ultrasound images see those tiny differences.
We developed a prosthetic arm that works based on ultrasound signals that can detect intentions of amputees for moving their fingers. So we can detect what fingers they want to move, even if they don't have the finger. It's just the phantom stamp that they are open.
For Jason Barnes, it has been life-changing.
Completely different. It's way more intuitive. A lot of the other previous prosthetics that are on the market only allow for certain grip patterns. What this allows me to do is do whichever grip I want on the fly without having to change modes or press a button.
As the machine analyzes more and more ultrasound muscle patterns, the prosthetic will get better at predicting what the user wants to do.
Different fingers would make the muscle move differently in different directions, sometimes to the left, sometimes to the right, sometimes faster or slower. We can do machine learning, which we do, to detect all of these patterns and be able to predict what is the finger that the amputee is trying to move, which is impossible with the noisy signals from the EMG.
The researchers say fine motor control prosthetics like these have all kinds of applications, not only for amputees, but also for stroke victims and anyone with limited movement. Kevin Enochs, VOA News.